Welcome back to the next session in Module 3, that is Programmer Logic Controllers. In the last class, you people have come across few of the topics regarding about the industrial robot. There, you people come across about the different parts of a robot controller. There are some joints and links we people have studied in the last session. In today's session, let us know few of the things regarding about the robotics. In that, I have written the topics I am going to cover in today's session. These are the topics I am going to cover in the today's session. That is nothing but the types of joints, robot wrist, types of drives, end effectors, sensors, functional requirements of robot control system. In the last class, while explaining the different parts of a robot controller, we come across few of the joints there. We don't know what type of joints they are using in the robot controller. Now, in the first topic, let us know about types of joints that are present in the robot controller. The first type of joints are nothing but the linear joint, orthogonal joint, rotational joint, twisting joint and revolving joint. These are the 5 basic types of joints. Okay, we know that joints are used to connect the link between one joint to the another joint. There is a link type of structure will be there. To connect that links or to operate any of the operations, we will go for using many of the links and the joints. Means you can observe here, if I in my right hand, you can observe here, there are 3 types of joints are there. Here one joint is present from the shoulder to the arm, and from ear to ear one more joint is there, one joint is here, one joint is here, one more joint is here, and 3 joints are present. In between them, these bones will going to act like a structures or the links. In similar fashion, here when it's come to the human beings are very versatile nature of a robot. If I compare with a robot, because we can do multiple type of rotations and multiple type of operations by using our arms. But when it's come to the robotics, in few of the cases, the wrist motions and the joint motions and the arm motions are very restricted, because their degrees of freedom will going to play a major role. For us, we have a lot of many degrees of freedom. When it's come to the robots, based on the joint, they will going to place it for the particular type of a robot. The degrees of freedom will get varied. It's nothing but degrees of freedom is nothing but the number of independent motions that will going to appear over there. That is about the degrees of freedom. Now let us know about the first joint, that is about the linear joint. When it's come to the linear joint, you can observe the diagram. This is the input link, and this is a joint where the input link and output link is get connected. Here the joint motion is only in linear motion, that is nothing but only the translation movement will be there. Only the translation movement will be there. With the help of linear joint, we can achieve the translation movement. Only in linear part the movement will be there. These kinds of joints are used for the stretching operations. For example, from here to here, I need to move the robot arm from one position to the another position without lifting from this place to that place, or from this position to that position. Means I need to move the object from this position to that position by dragging motion itself. During that time, I will go for using the linear joint. We can easily move the object. Okay, in linear joint, one more thing we need to know about it: the input link axis and the output link axis, the will be in the same direction, because they both are connected in opposite to each other, but the connection over there would be exactly at the center, but this output link will get moved inside that joint whatever they given over it. That is about the linear joint, and this linear joint is indicated with the symbol of L. Next is about the orthogonal joint. When it's come to the orthogonal joint, you can observe the T type of structure. Here the input link will be there and the output link will get connected like this. You can observe here input link in the horizontal manner and the output link is get connected in the vertical manner. Here I can move this output link in horizontal way, but it is get connected in the vertical manner. in these directions, and also it is also in a translation type of movement and linear type of movement, but the joints connection will be perpendicular to each other. Here input link joint is get connected to the output link in perpendicular motion, means the axis of input link and output link will be 90-degree apart. That is about the orthogonal joint. It is indicated with O symbol. When it's come to these kinds of joints, we can use this joints wherever the operations, for example, if I apply my common sense to rub the board, I can use these kinds of joints, orthogonal joints. Means only these kinds of movements are possible, but the vertical type of movement will going to appear here, because for the output link we are going to connect any of the end effectors to it. You can observe the joint motion. This is also a translation movement, but the output link movement will get differ based on the end effector. We will going to connect it perpendicular to the input link. Next is about the rotational joint. When it's come to the rotational joint, in rotational joint, the joint motion, you can observe here input link is get connected with the output link like this, and there the pivot joint type of structure is get connected from the input to the output. We can clearly observe this is a top view. Here the motion is possible only like the oscillations or swirling motion is possible. This kind of motion we can achieve with the help of rotational joint. And when it's come to the rotation is get constrained till the flexible movement of the output link till where it will going to touch the input link when it's come to the inward motion or when it's come to the outward motion, towards to the right, towards to the left, we can achieve, but most probably we can achieve 330 degree, 320 degree or 340 degree with the help of this rotational. 360 degrees is impossible when it's come to the rotational joint. Here R we are going to indicate with this rotational joint with R. Next about the twisting joint. When it's come to the twisting joint, with the name itself saying that twisting means twisting motion will going to happen in the input link and the output link. Here the joints are get coupled like this. The input link we can rotate like this, and also output link we can rotate like this. So twisting operations can be performed with the help of twisting joint. You can observe the joint motion. The joint motion will be in twisting type of motion can be achieved. This with the help of these kinds of joints, we can go for the orientation of the objects by holding it, or we can go achieve the rotational movement of the end effector with the help of these kinds of joints. And the last one is about the revolving joint. Here we have written the revolving joint. Here the joint for the input link, the output link is get connected 90-degree apart, but the rotation is possible in all 360 degrees. These kinds of revolving joints you can observe in the pen stand. There the pen stock they have provided over there. You can observe after fixing the pen cap to the pen, we can rotate that pen stock in all the degrees of freedom. With 360 degrees we can rotate it. This is about the revolving joint. We are going to indicate this revolving joint with V symbol. Okay, these are few of the basic types of joints they are going to use in robotics. Next is about, till now people have studied about the what are the types of joints were present over it. Next is about robot wrist. For us, we can observe the wrist. From the wrist, the fingers are get connected. We can do multiple type of operations, and we can go for gripping it. We can do whatever the necessary things required. But when it's come to the robots, it's very difficult, because we need to attaching that wrist part to the robot end arm. There we are connecting it. You can last class I have written the diagram of robot control structure there. To after the one of the link you can connect this wrist part. If you are connecting the wrist part means there based on the type of joint we are preferably using, the wrist will going to rotate. But when it's come to the wrist motions, we have three different types of wrist motions. You can observe the diagram here. This wave part is the connecting part to the hand arm, and this part is for the sliding movement in vertical direction, and this part is get connected to the last part, whether it is get connected to the any type of the grippers or to the tools. Means till if I cut my fingers till here, the number of rotations we can achieve with the help of the wrist. But in our wrist we can go for rolling movement, we can go for yaw movement, we can go for pitch movement, any other type of movements are possible. But when it's come to the robot wrist, we are to get the different motions and different rotations and different inclinations of our wrist, of the robot wrist, we are connecting the individual element from one element to the another element to the another element. You can clearly observe here. First, in the observation you can observe here, it is one type of rotational joint. It is a rotational joint which is connected to the base part of the wrist. You can observe here. Here the movement is possible in vertical movement, means the entire structure we can move in vertical motions. You can observe the rotation arrow, whatever I have written here. Pitch is nothing but the vertical movement of the wrist part in that direction. Means in our human wrist we can achieve all the three types of rotations, yaw, pitch and draw by a single joint. But here it is very difficult to achieve. Because of that we are connecting two different elements. That is about pitch. When it's come to the yaw, you can observe here in the yaw, the sliding motions or swiveling motions or the oscillating movement in one path and in one axis is possible. You can observe here there is no deflections over here. Here we are also using the rotational joint. And next, when it's come to the roll movement, you can clearly observe is nothing but we are rotating that wrist. That is the roll movement. Here 360 degrees of rotation is possible. Here we are connecting revolving joint or the twisting joint to the robot and arm. This is about the robot wrist, how they will going to perform. By applying the rotation, by applying the concept of how we will going to rotate our wrist arm, in similar fashion they have made this design and they have fabricated it for the robot wrist. That is about the wrist configurations or wrist motions. We have three different types of movements, that is nothing but the pitch, yaw and roll. Next we moving towards the types of drives. We already come across different types of controlling system and power system that are used, or the drive systems that are used in robotics and also in mechatronics. When it's come to that, when it's come to the robotics types of drives, we are going to use only three types of drives here, that is hydraulic drives, pneumatic drives and electric drives. Means once after building the structure of the robot, we need to give the power supply for it through any type of the medium. Based on the applications required in our daily life, we are going to use it. We already know about the hydraulic drives is nothing but it is run with within a medium of oil or water. When it's come to the pneumatic, we are going to use the compressed air. When it's come to the electric drive, we are using the electrical power supply. Okay, here when it's come to lifting the heavy loads, we are using the hydraulic type of drives. When it's come to the faster movement and for simple applications, we are using the pneumatic drive system. When it's come to the electric drive system, we can use for higher loads also, for lifting heavy loads, and also we can use it for the small loads also. But when it's come to the hydraulic and pneumatic, electric drives are mostly preferable in many of the robotics applications, because in electric drives we are using the servo motors and stepper motors in many of the joints. Even hydraulic and pneumatic drives are also used in the joints for the rotational movement, for the giving motions in linear path and for giving motion in rotary path. But electric drives are mostly preferable in many of the applications. 80% we are using the electric drives, because electric power supply is very simple to generate and very easy for us to go for applying it, and there is no lot of problems when it's come to the contamination problems in hydraulics. When it's come to the compression problem, we need to maintain the pressure in when it's come to the pneumatics. Those kinds of issues can be easily solved by using the electric type of drive system. That is about the different types of drives. Next is about the end effectors. What is this end effectors means? End effectors is in a part which it get connected to the end of the robot wrist. Once after designing this wrist, this end effector, whatever written over there, it is get connected to this part, means to the wrist part. End effectors are nothing but the fingers what we are using for the performing multi type of tasks in our daily life. In similar fashion, end effectors will going to play a major role in robotics. End effectors are of two types. First type is about the grippers and second type is about the tools. When it's come to the grippers, in grippers we have multiple type of grippers based on the application required in our daily life. First, if they formulate it, we'll go for the mechanical grippers. Mechanical grippers are used for lifting the loads or lifting the part or lifting the components or lifting any type of objects. We are using the mechanical grippers. There may be two or more than three fingers were get located over there. It is a mechanical type of structures will be there, similar to our fingers, whatever the human fingers present over it, similar to it the mechanical grippers will going to present. These grippers are identified and they are introduced in the robotics based on the type of part or the type of objects they are holding in our daily routine work in any of the industries or in any of the applications. Based on that, they have identified the grippers. Okay, next, when it's come to the vacuum type of grippers are used for the manipulating or to operating the glass objects. When it's come to the material of the glass, for us it is easy for us to lift the glass from one place to the another place with our hands. There is no need of such kinds of grippers for us. But when it's come to the robots, suction pressure we need to create it to lift the glass plate or the lift the glass plate from one place to the another plate. Their suction pressure is created, due to which those grippers will going to get attached with the glass material and it can be easily moved. That's why we are using the vacuum grippers. When it's come to the adhesive types of grippers, these adhesive types of grippers are mainly used for the holding some of the objects. It's very difficult to get hold in many of the industrial applications. If surface finish is more for many of the components, after finishing of the grinding operations of any of the turning operations, during that time it's very difficult to hold it. We can go with the help of the adhesive grippers. Again, when it's come to the dual grippers, these dual grippers are the grippers where the replacement of the grippers will be there. It is used for working in different multiple tasks. When it's come to the grippers, multiple tasks can be easily performed with the help of dual grippers. Next, about the sensory feedback grippers. These sensory feedback grippers, where the grippers were there, some kinds of touch sensors or force sensor are just attached to the grippers. Once after holding the object, it will going to detect which type of object I am holding or which type of surface I am touching, or the what amount of force I am it is get acted on the any type of the material or any type of the part or the object. There the feedback will get sent to the control system. By knowing that feedback, then it will going to perform the task how to hold that object and how to lift that object by amount of load that we need to apply on that particular object to lift from one place to the another place. That is about the sensory feedback grippers. When it's come to the multiple fingered grippers, these multiple fingers grippers are nothing but the human arms. We have different types of fingers. In similar fashion, multiple type of grippers were used. We can replace with, we can remove one finger, we can replace with another, we can remove other finger, we can replace it with, means simultaneously we can do the operations, and it is this type of multiple grippers are very useful for doing multiple tasks at a single time. And also when it's come to the standard grippers, these standard grippers are the grippers where we can overcome all different issues whatever we are observed right from the mechanical grippers. And the last one is interchangeable grippers. These are the grippers we can interchange it based on the operations we are going to perform. And also these kinds of grippers are designed in such a way that they can be easily get attached and removed from the robot wrist. That is about the end effectors in that first type of grippers. Next, when it's come to the tools, in many of the industrial applications, they not only go for handling the object, or they will not only go for material handling operations, they also go for some of the processing operations there. For when it's come to the processing operations, spot welding, spray painting, and some drilling operations, they will going to carry different types of operations there. During that time, we can directly connect the tools to the wrist end. Instead of grippers, we can directly connect the tool for many of the operations. That is why we are using the tools as an end effector. That is about the end effectors. And the next topic is about these, what are all the sensors that are used in robotics. You people have studied these kinds of topics and in-depth detail about the sensors in your 5th semester automation robotics. You people have come across lot of things over there. But in your syllabus, they have given only 5 different types of sensors, basic types of sensor what they are using nowadays. In that sensor, we know that it will going to sense the object when it's come to the its range, and by passing the light or by with the passing the waves, whatever it may be. Sensors play a major role in many of the robotic applications by giving the feedback back to the control system that whether it is detecting the right object or whether it is lifting the right part or the component, or right orientation is achieved in many of the operations, or material handling thing, or whatever it may be. Okay, these sensors are nothing but the feedback elements in the robotic system. In that, the first type of sensors we come across is about the tactile sensors. Tactile sensors are the sensors which are used for the purpose of the making the contact surface of any of the material and one. Means once the robot arm is get contact with any of the material part, their touch sensors will going to play a major role. This will going to give the feedback that you are touching the plastic material, glass material, metal material, or any other type of material. Means tactile sensors are nothing but we can going to classify it into two. One is touch sensor and the other one is a force sensor. These kinds of sensor, tactile sensors, will going to detect the surface of the object. By knowing that the surface, we can easily go for how we need to handle those kinds of materials. Next, when it's come to the force sensors, these force sensors are the sensors where it will going to give the amount of force is applied on the any type of the material or any type of the part. Means here force detection will be easily carried out with the help of this type of force sensors. Means the tactile sensors are gets attached to the whatever type of grippers we are using. There itself tactile type of sensors are get attached. We have the very good tactile sensor is nothing but our skin. We have that as an, it will going to act like a tactile sensor both in when it's come to the touch sensors, when it's come to the force sensor, we can easily detect by detecting any of the object. In similar fashion, when it's come to the proximity type of sensors, these are the type of sensor which are used to detect the range of the object. There many types will comes to the picture when it's come to the proximity sensors. Is about capacitive sensors, inductance sensors, different types of sensors are there when it comes under proximity sensors. Means to detect the range of any of the object or any of the part, will go for the proximity sensor. In similar fashion, when it comes to the optical sensors are the sensor. There's a different type of principles where they're going to use through beam type of sensors, reflector type of sensors, retroreflective type of method. There are different types of methods they are using for detecting the object. Here transmitter and receiver will be there. They will going to there a beam of light will going to impinge from the transmitter, at that will going to pass to the object, while there the reflector or some other thing type of structure material they will going to keep that object. The transmitted light will be passed to the object, that light again will come back to the receiver. By knowing that whether it is a surface finishing object or any other metal or any other type of material. And also these kinds of optical sensors are also used for detecting the range of any of the type of the material. When it's come to the application wise, there are a lot of things will comes to the. And next fourth one is about the machine vision. Machine vision is nothing but we are giving the eyes to the robots. It's nothing but for any of the machine we are giving the visibility or the optical type of vision we are going to provide it. Means till the time if we are using conventional machines, there it will be working blindly, but the operator is going to perform. If you give the vision for it, it will going to become the name. Machines which have the vision is nothing but for the guidance purpose and also for the identification of the process and also for doing some inspection techniques while doing the operation. We are giving the vision for any of the robots in many of the applications. That is about the machine vision. And some other type of sensors are used based on the environmental conditions also, and based on the type of application. Their temperature detections is also possible, fluid pressure detection, fluid flow detection, and some electrical voltage detection, current and ampere detection, etc. These are some of the basic things that are necessarily required in the robots when it's come to the sensors. Next is about robot control system. What are the different types of robot control system? We already come across how they will going to control it. The sensors will going to play a major, we know that. But when it's come to the robot control system, we have 4 types of robot control system, that is limited sequence control, playback with point-to-point control, playback with continuous path control, and intelligent control. Okay, when it's come to the first one, limited sequence control, means here the robot motion is limited to the floor space or the workspace. Within that workspace itself, the robot should go for doing the task. That is about the limited sequence control. Here the memory will not going to get stored to the robot. Every time the operator need to teach for the robot for moving from one point to the another point. These kinds of limited sequence controls are used in many of the applications, whether for lifting or when it's come to the pick and place of the object. First it will going to pick the object from here, again it will going to for the another, keeping the object at the another place. Again one more place it will going to pick the object, again it will going to lift. Means here the workspace is get limited for that particular type of robot. Next is about playback with point-to-point control. When it's come to the playback with point-to-point control, this is till more advancements to when it's come to the limited sequence control. Means they are moving some advancement or they are making some advancement towards in playback with point-to-point control. It's nothing but the operator will going to teach the robot how to keep the object from one place to the another place. Next, there is no need of teaching the robot again for doing the same task. Means automatically the robot will get stored the memory of that particular movement from one place to the another place. Again it will going to do this task by its own. There is no need of teaching again and again. Means once after teaching the new position or new movement to the robot, that is enough. It will going to operate continuously for longer duration of time for the same task. That is about playback with point-to-point control. When it's come to the playback with continuous path control, it is still more advancement when it's come to the playback with point-to-point control. In continuous path control, we'll go for some of the things about the linear interpolations or for the circular interpolation. For example, spot welding. In spot welding or in the welding operations, many of the welding operations, we can observe that if the continuous movement will be there, it will be in the form of linear interpolation. When it's come to the circular interpolation, different operations will come to the picture. There you can observe that the robot arm should get moved from first position to the last position till the end of the material where it is getting welded. Or when it's come to the spot welding, one position to the another position, again go back to the another position. There are different locations we need to share to the robot. There While doing the operations itself, the robot is doing the multiple tasks at a time. Means multiple axis control is possible when it's come to the playback with continuous path control. And the next one is about the intelligent control. In intelligent control, the robot will going to act like a human being there. While doing the operations itself, it will going to take some few of the decision making to do the multiple tasks or go for doing the multiple operations at a time. These are the things about the robot control system. Next is about the functional requirements of robot. Means what are the functional requirements of robot are necessarily required to implement or to introduce robot to any of the industries or to any of the applications. For that, robot they are usually preferably using for the first condition nothing but human operator is working in many of the hazardous environment. To overcome that, they are using this robot. And next, to when it's come to the doing the repetitive task, the human operator will undergo strain after doing the repetitive task. To overcome that, we are using this robot. Next, for lifting the heavy loads or lifting the some fragile materials, it's very difficult for the human operator to handle it in a safe manner. There we are using the robots. Next, for multiple shift operations. When it's come to the multiple shift operations, for a human operator means 8 hours per shift will be there per day. They need to work for 8 hours. Again, one more operator need to come back after completion of one operator. The same work again one more operator will come after 8 hours which get over. During that time, if we are introduce a robot there, 2 operators can be replaced and some task can be performed very neatly for a longer duration of time. Next is about the infrequent changeovers. In some of the times, some changeovers can be not made easily when it's come to the human operator because they are fixed for doing particular type of task in their routine work. But by using the robots, we can do it that. And next one is about part position and orientation. When it's come to the material handling and material loading applications and loading and unloading applications, that's part positioning and orientation is very much important. Whether doing some kinds of operations in any of the CNC machines or in any of the machineries, the robot should place the part in particular position in between the jigs and fixtures that are provided over there. And orientation is also very much important. And by considering all this, we will go for the applications. When it's come to the applications, they are used these kinds of robots in material handling application for loading or unloading or performing both loading and unloading at a time. And next, when it's come to the processing operations, some spot welding, spray painting applications they are using. And next, when it's come to the assembly operations, by bringing different parts in one location or in the conveyor for the get attached, get assembled for the different parts, they will go for the using these robots in many of the applications. In many of the car manufacturing industry, you can observe that. Within a short period of time, they will going to complete the entire assembly of a car. This is regarding about few of the topics when it's come to the industrial robotics. I have covered the types of joints, robot wrist, types of drive system that are present, end effectors, sensors, functional requirements of robot and robot control system. Okay, this completes the module 3, that is programmable logic control system. Thank you.